Even being aware of all my limitations, it was pure magic, and I believe they were happy in the brief moment.
USA just released fully functioning female robots. It seems that USA never backstalls from its position as the forerunner of all things technological. Let's take a look at the latest happenings from the American robot and AI arena. Algorithm for human-robot teams. As robots increasingly join people on the factory floor, in warehouses, and elsewhere on the job, dividing up who will do which tasks grows in complexity and importance. People are better suited for some tasks, robots for others. And in some cases, it is advantageous to spend time teaching a robot to do a task now and reap the benefits later. Researchers at Carnegie Mellon University's Robotics Institute have developed an algorithmic planner that helps delegate tasks to humans and robots. The planner, act, delegate, or learn, considers a list of tasks and decides how best to assign them. The researchers asked 3 questions. When should a robot act to complete a task? When should a task be delegated to a human? And when should a robot learn a new task? There are costs associated with the decisions made, such as the time it takes a human to complete a task or teach a robot to complete a task, and the cost of a robot failing at a task, said Shivam Vats, the lead researcher and a PhD student in the RI. Given all those costs, our system will give you the optimal division of labor. Facial recognition and Alzheimer's disease. In recent years, Alzheimer's disease has been on the rise throughout the world and is rarely diagnosed at an early stage when it can still be effectively controlled. Using artificial intelligence, KTU researchers conducted a study to identify whether human-computer interfaces could be adapted for people with memory impairments to recognize a visible object in front of them. Ritis Maskeliunas, a researcher at the Department of Multimedia Engineering at Kaunas University of Technology, considers that the classification of information visible on the face is a daily human function. When communicating, the face tells us the context of the conversation, especially from an emotional point of view, but can we identify visual stimuli based on brain signals? The visual processing of the human face is complex. Information such as a person's identity or emotional state can be perceived by us, analyzing the faces. The aim of the study was to analyze a person's ability to process contextual information from the face and detect how a person responds to it. According to Maskeliunas, many studies demonstrate that brain diseases can potentially be analyzed by examining facial muscle and eye movements, since degenerative brain disorders affect not only memory and cognitive functions, but also the cranial nervous system associated with the above facial, especially eye movements. Self-driving ATVs. Researchers from Carnegie Mellon University took an all-terrain vehicle on wild rides through tall grass, loose gravel, and mud to gather data about how the ATV interacted with a challenging off-road environment. They drove the heavily instrumented ATV aggressively at speeds up to 30 miles an hour. They slid through turns, took it up and down hills, and even got it stuck in the mud, all while gathering data such as video, the speed of each wheel, and the amount of suspension shock travel from 7 types of sensors. The resulting dataset, called Tartan Drive, includes about 200,000 of these real-world interactions. The researchers believe the data is the largest real-world multimodal off-road driving dataset, both in terms of the number of interactions and types of sensors. The 5 hours of data could be useful for training a self-driving vehicle to navigate off-road. Unlike autonomous street driving, off-road driving is more challenging because you have to understand the dynamics of the terrain in order to drive safely and to drive faster, said Wenshan Wang, a project scientist in the Robotics Institute, RI. Previous work on off-road driving has often involved annotated maps, which provide labels such as mud, grass, vegetation, or water to help the robot understand the terrain. But that sort of information isn't often available, and, even when it is, might not be useful. A map area labeled as mud, for example, may or may not be drivable. Robots that understand dynamics can reason about the physical world. The research team found that the multimodal sensor data they gathered for Tartan Drive enabled them to build prediction models superior to those developed with simpler, non-dynamic data. Driving aggressively also pushed the ATV into a performance realm where an understanding of dynamics became essential, said Samuel Triest, a second-year master's student in robotics. Military cannot rely on AI. Using artificial intelligence for warfare has been the promise of science fiction and politicians for years, but new research from the Georgia Institute of Technology argues only so much can be automated and shows the value of human judgment. All of the hard problems in AI really are judgment and data problems. And the interesting thing about that is when you start thinking about war, the hard problems are strategy and uncertainty, or what is well known as the fog of war, said John Lindsay, an associate professor in the School of Cybersecurity and Privacy and the Sam Nunn School of International Affairs. You need human sense-making and to make moral, ethical, and intellectual decisions in an incredibly confusing, fraught, scary situation. AI decision-making is based on 4 key components: data about a situation, interpretation of those data, or prediction, determining the best way to act in line with goals and values, or judgment, and action. Machine learning advancements have made predictions easier, which makes data and judgment even more valuable. Although AI can automate everything from commerce to transit, judgment is where humans must intervene. Many policymakers assume human soldiers could be replaced with automated systems, ideally making militaries less dependent on human labor and more effective on the battlefield. Soft robots navigate mazes without guidance. Researchers from North Carolina State University and the University of Pennsylvania have developed soft robots that are capable of navigating complex environments, such as mazes, without input from humans or computer software. These soft robots demonstrate a concept called physical intelligence, meaning that structural design and smart materials are what allow the soft robot to navigate various situations, as opposed to computational intelligence, says Ji Yin, corresponding author of a paper on the work and an associate professor of mechanical and aerospace engineering at NC State. The soft robots are made of liquid crystal elastomers in the shape of a twisted ribbon, resembling translucent rotini. When you place the ribbon on a surface that is at least 55 degrees Celsius, which is hotter than the ambient air, the portion of the ribbon touching the surface contracts, while the portion of the ribbon exposed to the air does not. This induces a rolling motion in the ribbon, and the warmer the surface, the faster it rolls. This has been done before with smooth-sided rods, but that shape has a drawback. When it encounters an object, it simply spins in place, says Yin. The soft robot we've made in a twisted ribbon shape is capable of negotiating these obstacles with no human or computer intervention whatsoever. Wi-Fi to help robots see and navigate. Engineers at the University of California, San Diego have developed a low-cost, low-power technology to help robots accurately map their way indoors, even in poor lighting and without recognizable landmarks or features. The technology consists of sensors that use Wi-Fi signals to help the robot map where it's going. It's a new approach to indoor robot navigation. Most systems rely on optical light sensors such as cameras and lidars. In this case, the so-called Wi-Fi sensors use radio frequency signals rather than light or visual cues to see, so they can work in conditions where cameras and lidars struggle, in low light, changing light, and repetitive environments such as long corridors and warehouses. And by using Wi-Fi, the technology could offer an economical alternative to expensive and power-hungry lidars, the researchers noted. That's all for this video, folks. See you another time.